Technology never ends at one point. Scientists started the evolution of electronics, followed by the discovery of a giant computer, the mainframe, a size of a room, to a desktop at home, ending with a laptop. Everything seems to be more smaller and more even efficient. The idea of using serials of one and zeros, which used in the traditional logic of every machine, might actually change, which is what we are going to find out later. Our presentation is about quantum computing, which is more of like scientific philosophy resulted in so many physical theories.
A quantum is a physical term referred to the very little entities that involve in an interaction such as atoms. The quantum computing is derived from the physical theory of quantum mechanics, which indicates mathematical description of particle-like and wave-like behavior and interaction of energy and matter. The founder of the quantum mechanics believed to be the German scientists Max Planck and Einstein, who followed Max Planck.
After reading many resources, I came across about how Einstein involved in this quantum mechanics. When Niels Bohr discovered the hydrogen atomic structure, Einstein used to have so many doubts about it, to the extent that he was debating with Niels Bohr. But Einstein seems to be convinced after Max Planck's experiment of heating a black body resulted in absorbing every frequency that passes through it, which made Einstein promote his theory of relativity. It mainly speaks about the relativity between two objects moving in space, relatively to the speed of light. Quantum mechanics. There is a physical theory known as the quantum electrodynamics. It describes with a high level of accuracy the interaction of atoms and photons. Quantum electrodynamics is formed along with the concept of quantum mechanics, but it has some certain rules that are not explained by the quantum mechanics. But how the two theories work? They are complementary of each other. The quantum mechanics is the primary theory described as the operating system, and the quantum electrodynamics is an application software. If we look to the quantum mechanics, we will look at several complex equations. However, the idea of quantum computing resulted in an experiment. In the 80s, scientists were trying to make the signal faster than light, which is a huge no-no when it comes to Einstein relativity theory. Instead, they thought of copying unknown quantum state, which in return make more possibilities of different states. At this point, it would make the signal faster than light, which resulted in the quantum computing idea. The quantum computing depends on two principles.
The two quantum principles. One, the principle of superposition says that if the world can be in any configuration, any possible arrangement of particle or field, and if the world could also be in another configuration, that the world can also be in a state which is mixture of the two, where the amount of each configuration that is in the mixture is specified by complex number.
Now let's look at this equation of superposition. We have the two parakeets, which is within the arrow. Parakeet which is used to describe the quantum state in a wave function behavior. The Greek letter describe the wave function, since we are talking about the atomic in an atomic level. A is actually the position. If we looked at the the parakeets with the A, it means the basic state in a position of A. As same of B, it's the basic state of 1 in a position of B. And they are both could happen. That's why the addition operation between them, which is describes the superposition concept. In the classical form of physics, if we say that as 0 it would give only 0 and 1 could only give 1, which is the main logic used in our machines for today, either 1 or 0, but not both states at the same time. Entanglement is the most important property in the quantum computing, where two or more particles can be linked, and if they are linked, you can change the properties of one particle, which in response to this change, the other particles that are linked, they would change too. However, scientists have controversial theories towards entanglement. There are two main theories. One, two particles can be linked and change each other without interaction. The second, the linked particles interact by hidden variables. An example of hidden variables is the torus. A torus looks like as a one circle. If we place it in two dimension, it would like two circles instead of one, which explains the hidden variables. The entanglement theory is a sequential theory. An example of this, the Schrödinger cat. The Schrödinger cat is placed in a box where there is a counter, radioactive element, and some poisonous gas. Within a defined time, for example, let's say an hour, the atoms of the radioactive may decay or may not. The counter can measure that. If it does measure the decay, it will release the poisonous gas and the cat will die. The idea that the Schrödinger wanted to show is that as long as the door is closed, the cat is in dual state, alive and dead. If the door is opened, then the quantum states is known of both states, dead or alive. There are other concepts beside the two principles. Decoherency, considered as a big problem of quantum computing. Coherent state means in a superposition state, but decoherency means if it interacted with the surrounded environment, it would fall into the classical physics. Which means if we wanted to make the superposition work, we should isolate it from the surrounded environment. The other concept is the Zeno effect, which helps to keep particles in a non-coherent state, in a non-superposition state. The last one is the multi-universe, not proven yet, but it helps us to understand the quantum physics better. In quantum physics, other universes should never affect our universe. In quantum physics, they are linked together that they could affect the state of elements in our universe.
Bit versus a qubit. As we all know that bits are the basic unit of information that are distributed by computer and digital communication. A bit can have one or two value which has two states, 0 and 1, usually in binary digit. The two value can represent logical value like Boolean, algebraic operation like plus and minus, the state of logic state like on and off. The usage of two-state value is very important for storage in the memory of the computer.
The things in quantum computing is slightly different here. In quantum computing, the basic unit is called a qubit. A qubit has two states in quantum mechanics system. A single atom of photon can have two states of polarization, vertical polarization or horizontal polarization, which allows the quantum mechanics to have the qubit in superposition of both states. If we looked at the picture below, we see a sphere shape of an atom, since we are talking about qubit. So this atom is spinning within two values, in the northern pole present as 1 and the southern pole presented as 0, since it has two states in one atom. There is a way of measuring other states on atom. It doesn't have to be the southern or northern pole, which are not accessible by the classical bits. However, a Bluetooth sphere is a way that can show multiple access states on the atom. An equator, which is on the red line, uh, uh, it has an accessible equation of this atom, which is the paraket of 0 plus the paraket of 1 per the root of 2. Shor's algorithm. Since qubits have so many complex large numbers to process, the need for inventing an algorithm to process large numbers was created under several complicated steps, known as Shor's algorithm. In the early 90s, it was known that quantum computer could be faster than any classical computer for certain problems. These observations made scientists curious about it. However, this changed in 1994 when Peter Shor, a scientist who devised a polynomial time algorithm for factoring large numbers on a quantum computer. The algorithm was seen as important since the difficulty of factorization, which is the base of most cryptographic systems today. The fastest algorithm available for factorizing a large number runs in exponential time, but Shor's algorithm runs on two computers as. This is an order of logarithm in n, an exponential of 2, and logarithm n multiplied in a logarithm of n. This is for a quantum computer, which makes it faster. The second, the order of logarithm and n for a classical computer. When the steps of Shor's algorithm applied on classical computer, the steps were implemented successfully. However, classical computers seem to be only observing the relatively small numbers. Quantum gates. As we all know, the logical gates are NOT, AND, OR, and XOR. Using them in quantum computing, it's reversible, which is the output you take it out of the input. In classical physics, the lost information occurs because of the wasted heat, which we have to get the output of the rest of the wasted energy. In quantum, the idea is a bit different, since the radiation of heat is included. It's like an output resulted to an input. Here we have an example of the NOT gate. If we applied it on the superposition equation, a position of a state 0 plus b a position of a state of 1, as this matrix, we have it here, it's going to be reversed. B and A, which is exactly the opposite of probabilities. B, a position of a state 0 plus A position of a state of 1.
Scientific view on quantum computing. Quantum computing seems to be holding so much promises for the future. Here is some of the scientific expectation about the quantum computing.
Teleportation. Would anyone imagine one day what if movies like Star Trek could come true? Traveling from one place to another without the complication of the common transportations? There are scientists who've made an experiment that proves that. One involving a photon and the other involving a superconducting circuit, which made the teleportation of the qubits travel from one place to another. Actually, what happens in quantum teleportation is slightly different. The bits themselves don't disappear, but the information about them do disappear. Imagine if we have A sender and a B receiver. A sends a sequence of zeros and ones, and B received them. And that's because the information about them do disappear is because A is transmitting the zeros and ones to B. But how the bits themselves don't disappear? It's because A contains zeros and ones simultaneously.
Related technology. Inventing the world's first quantum computer. D-Wave invented computer called Orion in 2007. The technology used in Orion computer called adiabatic quantum computing, which is based on superconducting electrons that can build large structures that behave according to the rules of quantum mechanics. The system operates with a thermal noise which makes this is decoherence time irrelevant.
There is an interesting story about this computer which was very controversial between scientists, since the D-Wave stopped publishing any single details about the structure of Orion computer, which brought the CEO of D-Wave company to explain that this is not a true quantum computer. Instead, it's a special purpose machine that uses some of the quantum mechanics to solve some issues. The statement seems to be very convincing. Quantum computing has so many doubts that surround it. Is it the door to every future technology? After observing all of the achievements that were made by scientists, we can say that quantum computing is still developing and we cannot really assume that it's not working. However, there are some advantages and disadvantages of this technology. The advantage is much more powerful, faster, smaller. Improvement to science can improve on practical personal electronics. Disadvantage is hard to control quantum particles, lots of heat, expensive, difficult to build, not enough is known about the quantum mechanics. Thank you for watching our presentation. I hope you enjoyed it and learned more about the quantum computing.